I'm going to start my today's session. My today's topic is Spearman's rank correlation, as you can see. And also besides this, I have written Karl Pearson's correlation coefficient. Now the heading is Spearman's rank correlation and Karl Pearson's correlation coefficient is written beside it. That means there must be some kind of relation between Karl Pearson's correlation coefficient and Spearman's rank correlation coefficient. To begin with, I must say that in today's class also I'm showing you the computational formula for the correlation coefficient. Correlation coefficient is our basic approach. This is the basic formula, that computational formula, and all other things which will be studied in this particular module, in this particular section of the module, will be based upon this. So this is my starting point once again, and I always want this particular formula to be in front of you so that you can always take reference from it. But my today's topic is not about the discussion of correlation coefficient, which has already been discussed twice. Today I'm going to start a topic which is called Spearman's rank correlation. Okay, so let's begin. The word rank we are all familiar with. A student sits for the examination, and students sit for examination and they get different marks, and we sequentially arrange the students according to their ranks. Okay. The basic difference between Karl Pearson's correlation coefficient and Spearman's rank correlation coefficient is, in Karl Pearson's correlation coefficient, when we calculate that, we actually need a bivariate distribution where the two variables capital X and capital Y are different. Say for example, we can say that we can consider a set of students, and they actually set for two different examinations, say mathematics and statistics, and their marks are given to us, and we are actually trying to correlate the marks of mathematics with marks of statistics. Okay, so marks of mathematics is a variable capital X and marks of statistics is the variable capital Y. But what we do in Spearman's rank correlation is that we consider the students who set for the examination for statistics and mathematics, and we actually rank them according to their marks. Rank of the students, suppose there are 60 students, just like in my class there are 60 students. I'm going to arrange them rank wise. Okay, and this rank is actually being associated with them depending upon their marks. If the student is sitting for two examinations, then a particular student will be arranged with respect to two different examinations, and he may get two different ranks. Obviously two different ranks. If a particular student is getting rank 1 for mathematics examination and rank 1 in statistics examination, then also I'm going to say that he has actually got two different ranks, because although his rank is 1, but this rank is associated with two different subjects. If I say that one of your classmates has got first division, has got first in a particular, has got first, just this, that doesn't bear any meaning. But if I say that he has got first, he is first in this particular competition or in this particular subject, then I am specific and you all will understand. First with respect to what? So if a particular student is getting a rank 1 for both the subjects, then these two ones are actually different, because one is associated with the statistics examination, and another one is associated with mathematics examination. So previously I was trying to associate the marks of the students, and my objective was to find a correlation between the marks. Now my objective is not about the correlation between the marks of the students. My correlation is about the ranks of the students, which has been obtained by the students in two different examinations. Obviously we can consider several examinations, but I am here not discussing multiple correlation. since we are sticking to bivariate distribution, so we shall always consider that the students is appearing for two different examinations. Okay, so two different ranks will be considered. Only two ranks will be considered. Now, if we do so, we need a formula, just like Carl Pearson's correlation coefficient formula. We need another formula which will help us to find the rank correlation between the ranks of the students. And that formula is given by Spearman, and the formula is written over here. Its name is Spearman's rank correlation formula, and it goes like this. When the pairs of observables, or observables means the things which can be observed. Variables are observables because variables can be observed. Okay, so when the pairs of variables or observables in the sample represent ranks with respect to certain performances of the individual, we can correlate the ranks together by quantifying the correlation between the ranks. Okay, and the computational formula, let me save the chat, otherwise I shall forget. Now, therefore, the computational formula for the Spearman's rank correlation is therefore goes like this. It is denoted by R suffix k. R stands for rank, Rk stands for rank, is equal to 1 minus 6 multiplied by summation over d square, di square, where I goes from 1 to up to n, and this entire thing is being divided by n into n square minus 1. Di is the deviation of the ranks of the pairs, and it is given by the formula xi minus yi for all I. What is xi? Maybe xi are the marks of the students or ranks of the students in mathematics examination. Xi is the rank of the ith student in mathematics examination. Yi is the rank of the same ith student in statistics examination. The difference of these two is denoted by di. Formula is very simple. Here 6 is a coefficient, is a factor, and which is getting multiplied by the term summation di square. We are calculating the di's, and we are actually taking the square of that, because you know that if I do not square the di's, then what will happen if I take the sum of the, if I consider the sum of the deviations, the sum of the deviation is always 0. So rank correlation will always be 1, and which is absurd. Rank correlation is not always 1. So we need to take the square of di. Okay, and this entire thing is being divided by n into n square minus 1, where n is the total number of observations. Total number of observations will remain same. It is because we have considered 60 students of my class, and they are sitting for the examination. If one student is not if one student is missing the examination due to his illness or something else, if he is missing the examination, suppose for example, we have 60 students in my class, and they have all set for the examination of CA1. In the CA2 examination, suppose Shupratik and Rohan, they are missing. They are not present due to some reason or other. Now, when I arrange the students with respect to their ranks in the two different examinations, CA1 and CA2, and since in CA2, Shupratik and Rohan, they are missing, then number of students now in CA2 is actually 58. They are not 60 because 2 students are missing. I cannot consider the rank correlation. I cannot calculate the rank correlation if I keep 60 students on the left hand side and 58 students on the right hand side. If Shupratik and Rohan are missing from the CA2 for the CA2 examination, then I shouldn't consider their marks also in CA1 examination to study the rank correlation. They are also absent in although they have set for the examination, their marks will not be considered, because otherwise the formula will become invalid. So I always have to keep in mind that the data on the left hand side should be of equal size as the data on the right hand side. That is the one primary condition for calculating the correlation, Carl Pearson's correlation coefficient or Spearman's rank correlation coefficient. Always keep that in mind. Problem number 1. I shall start with a problem which is very easy, then gradually I will go to the higher levels. Okay. During this problem, during this discussion of the problem, your questions may come to your mind, but I hope at the end of the class, you are going to get all of your answers. So just hold on. Yesterday's class has already been uploaded in YouTube. The ranks of same 16 students in mathematics and statistics are as follows. Two numbers within brackets denote the ranks of the students in mathematics and statistics. The ranks are given here pairwise. So if you count this yellow marked portion, you will find that there are 16 observations. 16 ordered pairs are there. And the first value of the ordered pair represent the rank of the student in mathematics, and the second value of the ordered pair represent the rank of the students in statistics. So rank of a student who has got the first mark in mathematics examination, he is also first in statistics examination. And who has got rank 16 in mathematics examination, he has got rank 13 in statistics examination. So we have to study whether these ranks are correlated to one another. What is the objective of this study? In statistics books, problems are given, theories are given, formulas are given, but there are very few books where objectives are discussed. Okay. But since statistics is a practical subject and it has lots of applicability in a system, in nature, so you always have to keep in mind that whatever I'm doing with statistics has to have some objectives. Previously also I mentioned that objective of the statistics will be discussed in module 5 and module 6. But still, since I'm doing the correlation, and correlation is one of the important tools of applied statistics, here also let me discuss a few things about the objectives. Objective of this study could have been, there may be many objectives. If one of your classmates is doing the experiment, doing this calculation, his objective may be different from one of another classmates of yours who is doing the same experiment. I can set one objective to the problem number 1. Maybe I want to judge whether a person who is good in mathematics is also good in statistics or not, or a person who is good in statistics is also good in mathematics or not. Maybe this is one kind of objective. You can set other different objectives. So assumptions may be different. Okay, but whether you assume something which is different from my assumption, but our basic tools to study it will remain same, and that is the basic tool. So I have ranked them accordingly, according to their marks. The marks of the students are not known to me. Here the ranks of the students are known to me, and I'm going to give the correlation. I'm going to study the correlation between the two. Okay. So this particular chapter is very interesting, and you will be amazed to see something which is coming gradually below. Okay. So what I have done technically, but let me discuss the technical issue first of all. I have prepared a chart. Always you have to have to prepare the chart to calculate. So I have prepared the chart, and I have tabulated the ranks of mathematics and ranks of statistics in the column 1 and column 2. Ranks of mathematics has been denoted by capital X, and ranks of statistics has been denoted by capital Y. And the deviation, and you see all the numbers of here are different from the numbers on the right hand, corresponding numbers from the right hand side. Okay. Okay. This is a special kind of this is a special problem. It's a very ideal situation. The situations in actual case are not that ideal. Okay, I understand what is coming to your mind, but I am going to come to that particular point later on. Now, suppose this is the ideal scenario. In ideal scenario, let me discuss the technical issue, technicality by which we can solve this particular problem. So what we do, we calculate the deviation. Deviation is denoted by D. You can use the symbol DI, or you can simply use D, doesn't matter. D means we are going to find the deviation, difference of ranks in mathematics and ranks in statistics. So all the differences of capital X and capital Y have been tabulated over here. And just like as I told you, The deviation, sum of the deviation is always 0. So if you take the sum of this column, you will find the total is 0. And if I, in the formula, if I were to consider summation di only, there is no justification in calculating rank, because rank correlation will always be equal to 1 then. So therefore, for this reason, d's are always squared. All the d's are always squared. So all the deviation are getting squared over here on the last column, and I am calculating their summation, and the summation is 136. After that, the matter becomes so simple. We use the formula. We just write, previously we wrote rk only. Now I am writing rk of x and capital Y. Rk means rank correlation. Rank correlation between which two variables? I am specifying the two variables, capital X and capital Y. Now, I am putting the values over here. If you can recall the formula of the rank correlation, I am again showing that to you. 1 minus 6 multiplied by summation di square divided by n into n square minus 1. So I am writing here 1 minus 6 multiplied by d square, that is 136, divided by 16 students are there because total rank is 16. So 16 multiplied by 16 square minus 1. And if you calculate it, it is 0.8. Now what is so interesting about this particular thing is that although Spearman's rank correlation coefficient formula is something different from the Karl Pearson's correlation coefficient formula. Karl Pearson's correlation coefficient formula involves covariance, variances, etc., etc. In Spearman's correlation coefficient formula, this covariance term is not present, this variance term is not present. It seems if they are not present. But very interestingly, you will note down that if you take the help of the Excel sheet, or you can do it manually, whatever. Now you are equipped with Excel sheet, so you can try it out. If you write all the ranks, if you tabulate all the ranks in the Excel sheet, and if you calculate the correlation will come out as 0.8. Now in the Excel sheet, the correlation key is not actually denoting the Spearman's rank correlation. In Excel sheet, the correlation actually, the codel, this key, codel, is actually denoting Karl Pearson's correlation coefficient. So what is the justification? Why is this beauty? The rank correlation coefficient is 0.8. Karl Pearson's correlation coefficient is also 0.8. It is simply because the rank correlation coefficient or Spearman's rank correlation coefficient formula is a special case of Karl Pearson's correlation coefficient formula. I have not shown the development of Spearman or the derivation of Spearman's correlation coefficient formula, which can be derived from Karl Pearson's correlation coefficient formula. But if you find it out in the book, and if you see the derivation, and if you try it out by yourself, you will find that all these things, covariances and variances, are actually present. Okay, so Spearman's rank correlation coefficient formula has got a special form, but its base is the Karl Pearson's correlation coefficient formula. So you can take the help to find the correlation between these two items. You can take the help of Spearman's rank correlation coefficient formula. But since I have already told you that Excel is a very powerful statistical software, so after today's class, you may try to find out the rank correlation key in the Excel sheet, and you will not be able to do so. Then you may think, sir has told to find correlation by Excel sheet, but rank correlation cannot be calculated by Excel sheet. So how can I calculate the rank correlation? Rank correlations RKXY is nothing but similar to RXY. So RXY, Karl Pearson's correlation coefficient, is coming out to be same as that of RK, 0.8. But you have to keep in mind that here capital X and capital Y, these two items are not the marks of the students in maths and stat. Here capital X and capital Y are the ranks of the students in both the examination, capital X and capital in maths and stat. And this is the reason for which in the heading of today's class, I have mentioned Spearman's rank correlation in the left hand side and Karl Pearson's correlation coefficient on the right hand side. I did it intentionally because Spearman, I wanted to tell you, and it will always try to make you focused that Spearman's rank correlation is a special kind. It has got some kind of relation with Karl Pearson's correlation coefficient. They are interconnected to one another. And this interconnection is Spearman's is a special case of Karl Pearson's correlation coefficient. Let me save the chat once more. People have written their roll numbers. Okay. Attendance is very essential. Okay. So I hope you have understood. And you see, when I substituted all the ranks, all the 16 ranks in the scattered diagram, the diagram came out to be like this. These are the scattered diagram of the ranks of the students in stat with respect to their ranks in maths. Okay, and they are highly correlated. Karl Pearson's correlation coefficient is lying between -1 and +1. Spearman's rank correlation coefficient is a special case of Karl Pearson's correlation coefficient. Since the lower limit for Karl Pearson's correlation coefficient is -1 and upper limit is 1, so Spearman's correlation coefficient's lower limit is -1 and the upper limit is +1. During the class, during the online class, I am actually presenting a note which I have prepared. But during the preparation, many things actually do not come to my mind at that moment or at the preparation of the note. Okay, many important points which actually I actually was supposed to include in the note. Say, for example, the limit of the Spearman's rank correlation. After that, after taking the first class of ECB, when I take the class of ECA, I try to rectify those things. But I will suggest you that during the discussion, I say many things which is not written in the note. So it is a good practice if you are listening to me, those who are listening to me carefully and attentively. I know that all of you are not listening to me. Maybe you are just I'm online and you are just listening to some sort of music. It may happen. It happens to each one of us. Okay, our mood fluctuates. We are not in a good mood always. But if you are listening to me attentively, then it is a good practice to sit with a pen and a pencil and a copy. If I say something extra, then you can note it down. Okay, so if I accidentally do not update my note, you can update by yourself. Say, for example, I am now saying the limit of the rank correlation coefficient is also -1 and +1. It is not there in the note, but you can note it down and you can keep it in mind. You can later add it to the your note or personal note. Okay. Here is another problem number 2. It is also a very interesting problem. It's something different from the previous one. Here it has been mentioned. The problem goes like this. 10 competitors in a musical test were ranked by 3 judges, capital A, B, and C, in the following order. The note is this particular problem is so its application is very clear to all of us. We always perform in the stage, and 3 or 4 judges are sitting, and they are judging us. Okay, it always happens. It happened to me. It happens to you. Okay, in the stage performance, in Saregamapa, it also happens. Now all the judges, suppose they are they are actually giving the ranks to the students independent of one another. Kumar Sanu is not discussing with Alka Yagnik while giving the marks. Alka Yagnik is not discussing with Shantanu Moitra to give the marks. If they are independent, suppose, of one another, there is no partiality. In that ideal scenario, ranks given to the 10 competitors by Judge A are as follows. Ranks given to the 10 competitors by Judge B are as follows, and ranks given to the 10 competitors by Judge C are as follows. Okay, and it is also an ideal scenario because all the ranks are very manipulated and they are very different to one another. Okay, so in this case, the question is, I have to find out using rank correlation method that which pair of judges has the nearest approach to common likings to music. Is it the pair of Kumar Sanu and Alka Yagnik, or it is a pair of Shantanu Moitra and Alka Yagnik, or it is a pair of Kumar Sanu and Shantanu Moitra? Right? So I have to find it out. That can also be found out using the rank correlation method. So how interesting it is, you see. So in this case, what we do, calculation is very simple. We tabulate all the items. In the first columns, 1, 2, and 3, we put the ranks by Kumar Sanu, ranks by Shantanu Moitra and ranks by Alka Yagnik. And then we find 3 deviations. The difference of Shantanu Moitra ranks by Shantanu Moitra and Kumar Sanu, difference of ranks by Shantanu Moitra and Alka Yagnik, difference of ranks by Kumar Sanu and Alka Yagnik. These differences are called deviations. Sum of deviations are always 0. And then all the deviations are getting squared. D1 squared, D2 squared, D3 squared, and their summation is being calculated over here. Now what you do, if you are fed up with manual calculations, you can take the help of Microsoft Excel. You can put these 2 items, X and Y, in Excel, and you can find the Karl Pearson correlation coefficient between these 2. You can put these 2 items in the Excel, and you can find Karl Pearson's correlation between these 2. And you can put X and Z in the Excel, and you can find the Karl Pearson's correlation coefficient. But if you actually want to try manually, then you can take the help of the rank correlation coefficient by Spearman, and you can individually find the rank correlation between X and Y, rank correlation between X and Z, and rank correlation between Y and Z. Individually, all the ranks have been found. Rank correlation between X and Y has been obtained as -7 by 33. Rank correlation between X and Z has been obtained as 7 by 11. And rank correlation between Y and Z has been obtained as -49 by 165. After calculating all the ranks, we will compare them, and we'll try to find out which of these 3 ranks or several ranks is maximum. Here, since this is the only positive item, it is easy to find the maximum item. If all the items are negative, you have to again find out the maximum of all the negatives. Maximum rank correlation coefficient is pointed out. It is RK's XZ, and that signifies that X is the rank by judge A and Z was the rank by judge C. Since the correlation between these 2 ranks is maximum, our conclusion will be the pair of judges capital A and capital C has the nearest approach to the common likings in music. So students, this is a very wonderful tool, rank correlation. Suppose in the coming Anachronos and HFest, if you get to hold of your ranks of your ranks of the participants by different judges, okay, you can, and suppose I'm sitting over here and another teacher is sitting over, I'm actually judging you, okay, I'm giving you marks, another teacher is giving you marks, and I'm not talking to that teacher, I'm behaving as if I don't like that teacher, okay, but you can study, okay, it's a secret between us, you can study whether I have a something common with that particular teacher to whom I am not actually befriending, or I am pretending to be not to be friend with him. Maybe we are friends, okay. So you can judge, you can try this, you can do this investigation by yourself. So it is a very wonderful tool, this particular rank correlation method. After discussing these 2 ideal scenarios, let me now go to the next problem, which is the most important one of the today's class. The problem number 3. The problem number 3 is actually asking you to find out 2 different things. One is, obtain correlation between the variables capital X and capital Y. Obtain the rank correlation coefficient for the following data. So I have to calculate both the correlations over here. Suppose capital X and capital Y, they are suppose marks, okay, or maybe something else, I don't know, because the justification of the values have not been given in the question. Suppose they are marks. It is easy to assume these values to be marks, okay. So the first part, small a, is very, the first part A is very simple. We have to consider the marks together, and what we are doing, we are putting the scatter diagram. We are trying to find out we are trying to guess the linear relationship between the 2 items, and after that we are calculating the Karl Pearson's correlation coefficient between the marks, and we are getting that it is nearly equal to 0.62, okay, moderate positive correlation. Next thing is the item B is very important. In item B, we have to arrange the data rank wise. Now carefully listen to me. First of all, what I am doing, I am putting all the marks, I am tabulating all the marks one after another, and I am putting the ranks beside it. So 80 has got rank 1, 75 has got rank 2, another 75 is present over here. It has, I'm putting the rank as 3, 68 has 4, and I'm actually marking, I'm not putting the ranks over here, I'm actually putting the serial numbers. Actually these 1, 2, 3, 4, these are not actually ranks over here, putting the serial number, increasing order or decreasing order. But here you see, this is the non-ideal scenario. That there are two persons who has got 75, and their ranks are different. Although they have got 70, both of them have got 75, their ranks are different. That shouldn't have been, that should not be, because we know there may be two first boys, there may be two second boys, but here although their marks are same, their things are, they are getting two different ranks, and this is not the ideal scenario. So if the ranks are of repetitive nature, say for 75 is being repeated twice, 64 is being repeated thrice, and 68 being repeated twice, and the rank y, in this situation actually defines the non-ideal situation. And in non-ideal situation, such kind of rank is called tied ranks. This kind of rank is called tied ranks. Okay. In tied rank, what we do, since a 75 is actually, I have written many things over here but since the time is running out, let me tell, and you just listen to me, and later you just compare what I have written over here. In tied ranks, what happened, we first of all identify, we consider the first variable, say capital X, which is nothing but a rank. This, with respect to that particular variable, we try to identify the numbers which has appeared more than one. Say for example, 75 has appeared more than once. So according to the serial number attached to this value 75 is 2 and 3. But to give an appropriate rank to this particular mark 75, we will try to find the average of these two numbers, 2 and 3. And the average of the two numbers is 2 plus 3 by 2, that is 2.5. The next number is 68, but 68 is the fourth number. Its rank will not be 3, its rank will be 4. That is all right. But 64 is again appearing thrice, and in the position 5, 6, and 7. So 5, 6, and 7 will not be its rank. Its rank will be 5 plus 6 plus 7 by 3 is equal to 6. Similarly, if we go to rank Y, then you will see that 68 is appearing twice at third and fourth position. So we will take the average of these two, 3 plus 4 by 2. So ultimately, by this calculation, what we are getting a new chart. And in this chart, the person who has got 80 is the rank 1 person. The persons who got 75 has got rank 2.5 and 2.5, because average of 2 and 3 is 2.5. 68, although this is 2.5 and 2.5, but see, in seriality, if you maintain the seriality, this is 1, this is 2, this is 3, virtually, that item is 4, appearing only once, and so I am putting here 4. 64, again repeated thrice, at 5th position, 6th position, and 7th position, I took the average of these 3, and the average is 6. And I put all the 64s, the ranks, all the 64 marks have been ranked 6 over here. Similarly, 68 appeared in twice in the Y series, and at the third and fourth position, and I have taken the average of these two, 3 plus 4 by 2, which is 3.5, and 3.5 has been associated to 68 and 68. So I have got 3.5 and 3.5. Once you prepare this chart, in step number 3, what you do, you prepare the entire chart, just like we do for the calculation of Spearman's rank correlation. So I have tabulated once again from the beginning the values of X, which are 68, 64, etc., goes up to 64, and ranks of, and the Y, the values of Y, which are 62, 58, and so on. Below X, we are writing the ranks of the X, and by taking the help from the chart obtained in step 2, we are trying to find out the rank of the mark, and we are putting it over here. 68, find out 68 in this chart, its rank is 4, put it over here. Find 64, its rank is 6, put it over here. Find, and in this manner, we are putting all the ranks in this way. in 3 positions 64s are there. You see 64, 64, 64. All the 64s have been put rank 6. Similar thing is done for y also. Below y we put the ranks, and by taking the help from the chart obtained in step 2, we put the respective ranks and we are putting it below the marks. Why am I doing so? Just like the order, which was the order by which the question was given, I am not trying to break the order. I'm not trying to break the order. I'm trying to keep the order as given in the question. And I'm putting the ranks over here in this manner. After this, my job is done. I'm calculating the deviations. Deviations are the differences of the ranks. Okay, this is not the difference of the values, remember. And then the deviations are squared. But here comes another important part. It is said that since several items are being repeated or several items repeated itself many times, suppose small m number of times, to calculate the rank correlation coefficient, I have to add a correction factor. I have to add a correction factor to the item summation d square. And that correction factor is m into m square minus 1 by 12. If a particular item repeated itself m times, the correction factor will be m into m square minus 1 by 12, and that will be included in the formula. That will be the change in the Spearman rank correlation coefficient formula. Okay. Now you see 75 repeated twice and 64 repeated thrice. So by using this particular formula, suppose I am considering the first item to be m1 and the second item to be m2. So m1's value is 2 because 75 repeated twice, and m2's value is 3 because 64 repeated thrice. So the correction factor for series X will be 2 into 2 square minus 1 by 12 plus 3 into 3 square minus 1 by 12, which is equal to 5 by 2. If we go to series Y, the value 68 repeated itself twice, and therefore this is the only value which repeated itself, and the correction factor would be 2 into 2 square minus 1 by 12. So we have got actually two correction factors, one for the series X, which is 5 by 2, another for series Y, which is half. And after getting all of this, I'm putting the value over here like this. So the rank correlation coefficient between X and Y would be 1 minus 6 multiplied by summation di square plus first correction factor for series X, which is 5 by 2, plus second correction factor for series Y, that is half, divided by n into n square minus 1. And n is the total number of items. There were 10 items. So 10 into 10 square minus 1, that is 10 into 99. And ultimately we are getting the rank correlation coefficient to be 0.545. Rank correlation coefficient is lying between -1 +1 and cannot be less than -1 and it cannot be greater than +1. So students, this much for today. I hope you have understood what I actually tried to say to you. Try problems from the book, take problems from the book and try to do the problems manually, and as well as by the Microsoft, as well as by using Microsoft Excel. It will be beneficial for you. So this much for today. See you day after tomorrow. Till then, bye.